should take it slow.
Everyone, and today we'll be doing integration. Now, if you remember, a couple of videos ago we did a topic known as differentiation, and this is the opposite of differentiation called integration. So, in other words, we're doing differentiation backwards. So, first of all, the symbol for integration is this symbol right here. Kind of look like a really big S, and you would now have a function. Let's say we have x squared, then you have dx, and I'll just go ahead and show you how we come about to this. So let's say we have an already differentiated function dy dx being equivalent to x squared plus 4. From here, we can now, the dx over here is dividing, so we can bring it over and allow it to multiply over this side. And then what we'll do is we'll take the integral of both sides, and the integral of dy is just y, so we'll end up with y equals the integral of x squared plus 4 dx, and of course you'll integrate all of that and you'll get back to your original function. In other words, it's how you get back to the original function of a derivative. And just like I mentioned that derivatives can be used to find gradients, integration can be used to find area underneath a curve. Now, let's show you an example of an integral. Let's say we have the integral of x squared dx. So, what would you have differentiated to get to x squared dx? So firstly, you know that you would have it would have had to be something with cube for you to end up with squared, because when you differentiate a cube, you know, you'll take away from the power and get a squared. Also, this is 1x squared, which means that when you multiply the 3 by the x, then the 3 would have had to cancel out, which means that there would have had to be a denominator here. Now, of course, some people can do it like this, but for others, you may need to understand it via a formula. So here we have the formula here, but I'll just write it a bit bigger. So a general formula for an integral is integral of xn dx no apologies, x to the n. The integral of x to the n dx is equivalent to x to the n plus 1 all over n plus 1. So yeah, as you can see, we did that there. And one thing you must remember is that you must add plus c. Now, why do we add plus c? Because when you differentiate, all constants become 0. So this c is here to represent all possible constants. Because the constant in an equation, let's say we have a graph of an equation. The constant for the equation is where it cuts the y-axis. So we have to add a plus c to represent all the possible places that the one curve could have cut the y-axis, because when we differentiated it, we got rid of the constant. So if you're doing indefinite integration, you must always remember the plus c, else the answer will be wrong. Okay, so now let's move on to theorems behind integration. Okay, so theorem number 1. Since d dx of a constant c equals 0, then integral dx of 0 just equals a constant. So the integral of 0 is just a constant. Now, theorem number 2. Since d dx of x plus c equals 1, then the integral of 1 dx, or you might just see them have it here as dx, because you're just multiplying by 1, will equal to x plus c. Theorem number 3. Since d dx of ax plus c equals a, then the integral of a dx equals ax. So the integral of any number just means that number times x. So integral of 2 dx is just 2x plus c. Theorem number 4. Integral of a f of x dx is equal to a times the integral of f of x dx. What this means is that, let's say for example, we have the integral of 3 times x squared. We can let f of x, a function in x, be equal to x squared. And so this integral here of 3x squared dx is going to be equal to 3 times the integral of x squared dx. So in other words, you can always pull out the coefficient of the function, because even you'll see in here the formula I showed you earlier didn't involve the coefficient of the x squared term. This is a way you can get rid of that coefficient, by bringing it outside, and it makes it all easier. Now, theorem number 5 and theorem number 6 are quite simple. Just like with differentiation, where you would differentiate each term at a time if it was summing or being a difference, is the same thing with integration. So if we had the integral of 4x squared plus 2 dx, we would do this as the integral of 4, going back to an earlier theorem, of 4 times x squared plus the integral of 2. Of course, you remember the dx. And when you finish both of them, it's supposed to be 1 plus c. And it's a similar thing for this with the differential. It's just instead of sum, it's a difference. So yes, that's the basic of integration. On my next video, I will talk about the application, so just finding area under a curve, as well as other things in integration. Thanks for watching. See you next time.
Tell me pretty lies, look me in the face, tell me that you love me.